Hey everybody, so yesterday we started talking about solutions with linear equations, lines on a graph, and then what happens when we have two lines on a graph. So this is a continuation of our notes from yesterday, so if you have those, go ahead and take that out. But I want to talk a little bit about a review of what we talked about yesterday, just so that we're all on the same page, and then moving on to a system of two linear equations. So first question here says, how many solutions does one line on a graph have? Now, if we think about a line on a graph, if I draw a quick sketch over here of a line on a graph, solutions come in the form of points. So all of these points that are on this line are solutions to the linear function. Now, a solution is in the form of a point, so there are infinitely many solutions to a linear function. Now, what a solution means is if we take an equation, like for example, if I looked at this one and I said it was y equals x plus 2, like maybe I said that that was the equation for this graph, then a solution is if I picked any point on this graph, like if I picked this point right here on the graph, what that solution means is it makes this equation true. It makes it a true statement. So let's say the coordinates of this point are 1, comma 3. Well, to double check to make sure that that is actually a solution is over here is if I plug in those numbers. Plug in 1 for x, plug in 3 for y. Does that make a true statement? Does 3 equal 1 plus 2? Yes, it does. So that would be a solution. So that means that 1 comma 3 is a solution. And remember, there are infinitely many of those solutions that are on that graph. Any point that's on that line. But then if I picked a point, let's say I picked this point down here, and let's say that that point was 4, negative 5. And I tried plugging that into my equation. Then I would have negative 5 equals 4 plus 2. Is that a true statement? Does negative 5 equal 4 plus 2? Well, that's false because 4 plus 2 equals 6. So that means that the point 4, negative 5 is not a solution. So if it makes the equation true, it's a solution. If it makes the equation false, then it's not a solution. So then if I look at two lines on the same graph, we talked about how there are three different options. Option number one, kind of the most common option, is if I have one line going this way, and I have the other line going down like this, that would have one solution. This has one solution. I'm going to move this down a little bit. That means that this has one solution, and we call that solution the intersection point, where our two lines cross each other. Sounds very similar to intercept. That intercept point is where the line crosses the axis, and intersection point is where two of our lines cross each other. So in this case, this point right here would be our one solution. Then on the other hand, I have two other options. To get no solutions, I would have a line that looks like this. And then to have no solutions, they just can't cross each other. And two lines that don't cross each other, those are called parallel lines. No solution, parallel lines. And then the last option is a little funky. If I draw it on a graph, the last option would mean I would have one line going like this, and then when I go to draw the other line, it just ends up right on top of it. So those are our three options. This last option would mean that there are infinitely many solutions because they are the same line. So either it has one solution, it has no solutions in common, or it has infinitely many in common, meaning that the lines are right on top of each other. And then we talked about there are 3 ways to solve systems of equations, and today we're going to talk about that first way, which is graphing. So I want to do a quick refresher on how to graph a linear function. Remember, when we're trying to graph, our goal is to get it in y equals mx plus b form. So we're trying to get the y by itself. So in order to do that, I need to make my t-chart. Make sure as I'm going through this, you're pausing it. I'm going to go through it kind of quickly, but if you're struggling keeping up, make sure you pause it, write it down, and then follow along, so that way you know what's going on. So here we're trying to get y by itself, so we're undoing order of operations, so we get rid of the addition part by subtracting 2x on both sides. Cancels out on the left side. Remember to bring that negative down, negative 3y. On the right side, we're going to be big brain because our end goal is to have mx plus b, so we're going to put our mx term first, so negative 2x, and then plus 9. Last thing we're going to do is divide by negative 3. Whatever we do on the left side, we have to do to everything on the right side, so divide everything by negative 3. To get y equals negative divided by a negative makes it a positive 2/3 x. 9 divided by negative 3 gives us negative 3. So then when we put this on the graph, our first point is at the y-intercept of negative 3. So I'm going to go down 3. Then from there, my rise is 2. My run is 3. So that means I go up 2, right 3. Up 2, right 3, up 2, right 3. And I can do the opposite of that. I can go down 2, left 3, down 2, left 3, down 2, left 3. Now, it's going to be super, super important that you try to draw as many points as you can, because when we do systems of equations, we're looking at where do these lines cross each other. And if you draw just a squiggle or a quick line, it's going to be very hard to tell. So draw as many points as you can, so that way it's really easy to tell where they cross. So here is that line on a graph. All right, so now we're going to look at what happens if we have 2 lines and it tells us to solve the system of equations by graphing. So all we're going to do is we're going to take both of these lines and we're going to put them on the same graph. Put the directions down a little bit. So the first one, we've got y equals 1/3 x minus 4. I'm going to do this first line in red. If you have multiple color pens, this would be a great time to use them. So I'm going to start down at negative 4. And then my slope is 1/3, which means I'm going to go up 1, right 3, up 1, right 3, do the opposite, down 1, left 3, down 1, left 3, would be right here, down 1, left 3, and then draw my line in. Again, try to draw as many points as you can. Next one I'm going to do in blue. Start up at 4. And then whenever I have a minus sign in the middle here, I'm going to float it up to that top number so that way I know my rise is negative. So I have to go down 7. So down 4 and then 3 more, and then right 3. And then down 7 would kind of put me off the graph, and I can't really go up anymore. So this is as many points as I can draw for this one. So I'm going to draw my line in as best as I can. So then my solution is where these lines cross each other. So my solution for this one is this point right in here. And the coordinates of this point are 3, -3. So for this one, they have one solution. And that solution is 3, -3. Easy as that, just graphing both lines, figuring out where they cross. Now, one thing you can do is you can check your solution. You can plug in 3 as your x, -3 as your y, to see if it makes a true statement. In this top one, if I plug that in, I would have -3 equals 1/3 times 3 minus 4. 1/3 times 3 is just 1. So I would have -3 equals 1 minus 4. And -3 does, in fact, equal -3. So that makes it a true statement. I can do the same thing for here. -3 equals -7/3 times 3 plus 4. Well, that would leave me with -3 equals -7/3 times 3 is just -7 plus 4. And yes, -3 does still equal -3. So it works for both of them. It makes both equations true. So 3 -3 is our solution. All right. So the reason why we've been practicing rewriting in slope-intercept is because a lot of times they're not going to give you an equation in slope-intercept. It's going to look a little bit different. So here we've got another problem where we're solving by graphing. And we've got the two equations. We've got y equals -3x plus 5 and 5x minus 4y equals -3. First one's really easy because it's already in slope-intercept, so I'm going to go ahead and graph it. Start up at 5, go down 3, right 1, down 3, right 1, down 3, right 1, and then draw in my line as best as I can. Second one's not so easy because it's not in slope-intercept form, but we can get it there. This is where we just need to make our t-chart and get y by itself. So I'm going to subtract 5x to get -4y equals -5x minus 3. Divide everything by -4. And that's going to leave me with y equals 5/4 x plus 3/4. Now, you might be thinking to yourself, graphing is super easy because you just look at the graph, where do they cross? Graphing is not always going to be our best method, and we'll see that in this case. So if I go to graph this, I have to start at 3/4, which is right here, and then I have to go up 5, right 4. So from there, I have to go up 1, 2, 3, 4, 5, and write 1, 2, 3, 4. And I can also go down 1, 2, 3, 4, 5, and right or left 1, 2, 3, 4. And then I'm going to draw my line to the best of my ability here. Now this one, it's kind of hard to tell. It's a little bit easier in this one, but let's double check. It looks like it crosses right here at 1, 2. But then let's see what happens when we check it. In our top one, if I plug that in, 2 equals -3 times 1 plus 5. -3 times 1 is just -3, plus 5 is 2. So that one, it works, which makes sense because that one was the easier one to graph. Now, if we plug in 1, 2 into this one, I always like to plug it back into the original equation because sometimes it might be that the mistake was converting it. So I'm going to go back to plug it into the original equation. 5 times 1 minus 4 times 2 equals -3. Well, 5 times 1 is 5. Minus 8 does, in fact, equal -3. So we lucked out here where it worked. Now, a situation where you might not want to use graphing is whenever you have fractions involved as your y-intercept, because then it can get a little little hairy, because then if you get a point that's kind of in between and it's kind of hard to tell, graphing might not be your best solution or your best way of doing it. Graphing is super easy though, because you just graph it and then look at the graph, but it can be tricky. Now, we gotta make sure that we answer the question. The solution in this one is 1, 2. Make sure it's very clear what your solution is. Now, tomorrow we're gonna look at some of those other situations, and we're gonna do a lot more practice on systems by graphing. I just wanted to make sure that we went through a couple examples together. That way you have these down on your notes to go off of. Remember, we've got that homework assignment. Otherwise, have a great rest of your day.